Hello everyone. So today's lesson is for Tuesday the 31st, and we're going to be doing slides 1 through 4 on what would have been the day 2 notes for section 5.6. I'm going to call it just section 5.6 day 3 for ease in our Google Classroom. And your homework for this evening is going to be page 322 to 324. You're going to be doing problems 44, 47, 106, and 107. So there's just 4 problems. Please have those submitted by midnight on Tuesday evening, so that way I can post the answer key for you to check at 8 a.m. the next morning. Now let's get into our lesson. So we're going to start with doing our warm-up. We're going to solve this logarithmic equation. So first thing you should recognize is that they're both base 6 and they're being added. So we could rewrite that as multiplication. And then you should recognize then that you have to, let me see if I can get this a little bit clearer for you guys. There we go. Okay, so then we have to multiply those together. So that becomes x squared plus x minus 6 when we multiply them together, because negative 2x plus 3x becomes positive x. And then we can rewrite this as an exponential equation. So 6 to the first equals the argument. So 6 to the first equals x squared plus x minus 6. 6 to the first is just 6. So now I'm going to solve this by subtracting 6 on both sides, setting your quadratic equal to 0. And then this can easily be solved by factoring. What multiplies to give you negative 12 and adds to give you positive 1? Well, that's going to be x plus 4 and x minus 3. So then you get 2 answers. X equals, well, I'll set x plus 4 equal to 0, and I'll set x minus 3 equal to 0. So our 2 answers are negative 4 and 3. Sorry, it was a little off the screen. Okay, and you should then check to see if those are viable solutions. If I were to plug in negative 4 back in, well, negative 4 plus 3 is negative 1. The argument can't be negative, so that answer is excluded. And then if you plugged in 3, both of those arguments ended up being positive, so your answer is 3. Next, so these are going to be a little bit different. You are going to need a calculator for these problems, so please have a calculator ready, or download a app on your phone. There are some free graphing calculator apps there. So first thing you're going to want to do is turn this into a logarithmic equation. So since 4 is the base, we're going to do log base 4 of 97 equals x. And let's just double check. 4 to the x equals 97. Perfect. Now, there's no way to solve this except to use our change of base formula. So we can either do regular log of 97 divided by log of 4, or we can do natural log of 97 divided by natural log, of 4. Either way, when you type it into your calculator, you will get your solution, and it should be 3.3 approximately. Let's type that into our calculator so you can see. So if I do log 97 divided by log of 4, I get 3.3. If I did natural log of 97, and it froze. Let's try that again. Divided by natural log of 4. Again, you would get 3.3. So that's perfect. Okay. And now we're going to solve the second equation. First thing you have to do is isolate the exponent. So we need to isolate this by getting rid of the 7 that's being multiplied. So to get rid of multiplication, you divide both sides by 7. So you get 3 to the x equals that fraction of 29/7. And now we're going to change this into a logarithmic equation. So log base 3 of 29/7 equals x. 3 to the x equals 29/7. Perfect. Now again, we're going to need to use our change of base formula. So that's going to be either log of 29/7 divided by log 3 or natural log of 29/7 divided by natural log of 3. But either way, when you type this into your calculator, just make sure that you are closing this parenthesis after you do the fraction of 29 divided by 7. So I'm only going to do one of them. I'll just do it with the log. But 29 divided by 7. Close that parenthesis and then divide by the log of 3. You're welcome to put it in as a regular fraction by hitting alpha y equals or whatever the shortcut that you use is, but you don't need to. So then on this one, you get 1.3. Now in your homework, it does ask you to round to, I believe, 3 decimal places, so just pay attention to that. And these it didn't specify, so I'm just rounding to the 1. Okay, so there's the answer of 1.3. Let's go on to the next one. Okay, so on this next problem, we have 7 as our base on the left and 5 as our base on the right. So because they are not the same base, we need to change them into natural logarithms or a regular log to get them into a logarithmic equation. So it doesn't matter which one you use. I'm going to use ln just for this problem. So we'll do ln on both sides. So now I have ln of 7 to the x equals natural log of 5 to the 3x minus 2. Now, both of those have exponents, so we need to then take those exponents and bring them out in front as factors. So now we have x ln of 7 equals 3x minus 2 ln of 5. Okay. And our goal here is to get the x's together. So right now we have 3x minus 2 both being multiplied to ln of 5. So I'm going to go ahead and distribute so that way both of those get multiplied out. So I get 3x ln of 5 minus 2 ln of 5 equals x ln of 7. So now there are 2 x terms here and here. So this is an x term and this is an x term. We want those to be on the same side of our equation. So I'm going to go ahead and subtract this from both sides. I'm going to subtract 3x ln of 5, subtract 3x ln of 5. So now I have, I'm going to just scooch this over, x ln of 7 minus 3x ln of 5 equals negative 2 ln of 5. Okay, And by doing that, you should see that both of these are x terms, and we can factor out the x as a GCF. So take the x out, that leaves you with ln of 7 for the first term, and minus 3 ln of 5 for the second term, equals negative 2 ln of 5. Scooch this down just a smidge. Okay, and now I want to solve for x. This parenthesis is being multiplied to x, so to get rid of it, I'm going to divide by all of that. I'm going to divide by ln of 7 minus 3 ln of 5. I'm going to divide that by ln of 7 minus 3 ln of 5. So x is going to equal that fraction, negative 2 ln of 5 divided by ln of 7 minus 3 ln of 5. And honestly, because this is being divided, you can either put it into a fraction, or you can just hit the division key and then just make sure you put parentheses around the entire denominator. It doesn't make a difference which one you do, but let's type that in. So if you want to do a fraction, second y equals, you can hit the fraction that way, and then you don't have to worry about the denominator being in parentheses. But let's type in negative 2 ln of 5, go into your denominator, and then we have ln of 7 minus 3 ln of 5. And you get 1.1167. So if we wanted to round this to 3 decimal places like on your homework, that would be 1.117. And again, had you used regular log, that would be the same exact thing, except for ln's, they would be replaced with logs. All right, last problem in our notes. So we're looking at the resident population in the United States in the year 2015, and it was 320 million people, and it was growing at a rate of 0.7% each year. So we are assuming that this growth rate continues. So they gave us a model, an exponential equation, 320 and then times 0.1007 raised to the t minus 2015. And this represents the population P, so that's the population in millions, in year T. So T is the actual year that we're looking at and not the number of years. So according to this model, when will the population of the United States be 400 million? So we want to know when the population, that's going to be P. And we want to solve for when. So we're trying to figure out what is T. We're solving for T. So P of T equals 400 million. It's already in millions, so we don't need to add all those extra zeros. We're solving for T. Okay, so let's do that. Let's replace 400 in for P of T there into our equation, and let's solve. Okay, so just like before, up above, actually in the previous problem before that, we have 320 out in front. We need to isolate the exponent, the exponential part of the function. So let's divide by 320 on both sides. Now when you do that, you get a decimal that comes out to be exact. If not, leave it as the fraction, but this actually comes out to be 1.25. The 400 divided by 320. So 1.25 equals 1.007 to the t minus 2015. And now we could then write this as a logarithmic equation. You can either do natural log or log. It doesn't matter which one. This time, since above I did natural log, I'll do log on these two. So log. So now I have log of 1.25 equals log of 1.007 to the t minus 2015. Next step is we need to get rid of that exponent and bring it in front as a factor. So I'm going to just come up here to finish my work. Log of 1.25 on the left equals t minus 2015 times log of 1.007. Okay. Next step, I want to solve for t. Now you can go ahead and distribute it if you'd like, but you do not need to. So here's t. You can distribute it, or you can just go ahead and realize, well, all of this is multiplying to that quantity, so I can just divide by log of 1.007 on both sides. And when I do that, I get log of 1.25 divided by log of 1.007 equals t minus 2015. And the next step would be just to add 2015 to whatever this comes out to be. And that's going to give you what t is. So let's go ahead and type that into our calculator. So hopefully, let me switch that over so you can see what I did. So we got log 1.2, and it froze again. Just give me one more second here. Oops. (1.25) divided by log of 1.007. Enter, and then that is going to be added to the year 2015. Okay, so then that gave us t to be 2047 is the year. So because we're talking about years, we want to be rounding, so that's the year 2047, thanks to that being 0.989. Okay, and now we just have one more part of our problem to do. Same thing, but now they're asking us to figure out what is so when the population is 435 million, when is that going to occur? So again, we're solving for t, but this time when the population is 435. So we're going to replace p in that equation with 435 million equals 320, 1.007, t minus 2015. Now, the same idea is happening here, except we have different values. You have to divide by 320 first. This does not come out to be a pretty decimal, unfortunately, so I'm just going to leave it as 435 over 320 equals 1.007 t minus 2015. When I change this to a logarithmic equation, log of both sides, I get log of that ugly fraction equals, and again, I get log of this with that exponent, so I'm just going to go ahead and bring that right out in front. 2015 log of 1.007, and hopefully you can see that this and this are identical except for this value, right? So we know we can keep going if we want by dividing both sides by log of 1.007 and then add the 2015, but you should hopefully recognize that they're asking you to do the same exact thing as above. So what we could have done is just taken this last equation and replace 1.25 with this fraction and figured out what that is using our calculator. But I'm going to keep going with this just so that we have the work all done out, because it's always nice to have an extra explanation of a problem. So that equals t minus 2015. So then you would just have to add 2015 to both sides, and that's going to give us what t equals. So let's go into our calculator and let's type that in. So log that ugly fraction of 435 divided by 320. And this calculator hates being used on the desktop and not on the smart board, which is what it's meant for. So that's why it keeps freezing on me. I apologize. At this point, I think I might just use my cell phone and use the graphing calculator app on that. 320 divided by log of 1.007, and then just add the year 2015. And you get the year 2059. So in the year 2059, that's going to be when the population reaches 435 million, according to this model. All right, and then there's two more problems. I'm not going to go through them. I'm just going to tell you what the answers are in case you need more practice and want to do that. So this first problem right here is going to be x equals 2 for your solution. And the last problem is going to be x equals 4. Let me know if you have any questions, and sign up for office hours or email me and we can set up an appointment, or I can just answer your quick questions via email. But either way, good luck. Let me know if you need anything. And again, the assignment is posted on Classroom. Take care.